Yeah. So in the last class, we discussed what are the different IoT architectures, right? To overcome the challenges that we discussed in the first chapter, many architectures were designed, out of which the first one we studied is IoT. The first one, that is one M2M architecture, right? So that is the first one we studied. One M2M IoT standardized architecture, wherein three layers were there: applications layer, service layer, and network layer. After discussing this architecture, then we moved on to the next topic, that is the IoT World Forum standardized architecture, where seven layers are there, and the functions of each layer also were discussed, right? And after discussing those two models, all the seven layers are reduced into three layers, and a simplified IoT architecture was given, right? So where there were, the architecture is presented as two parallel stack. One is that IoT data management and compute stack, and other parallel part is core IoT functional stack, right? So, so that is here. I forgot to display that. Yeah. So this is the first architecture we discussed. This is the second one. Then we discussed all the functions of each layer. And this is the simplified architecture, IoT architecture, where you can see all the seven layers are reduced and three layers are formed. And you can see this framework has two parallel stack. One is core IoT functional stack, and the parallel one, other part of the parallel is IoT data management and compute stack. So say at each level data will be there, right? To process that data, that means to manage that data, the respective layers are given here. So with respect to sensors and actuators, edge layer will take care of that. At the communication network, fog layer will take up, and at the application level, cloud will take care of. Okay, this is what we discussed, and what each layer includes, that is also we just discussed. And each layer of the simplified architecture also I explained in the last class, right? So I'll move on to the last part. Okay, let me again consider the same diagram. Yeah. See here, we discussed things, that is sensors and actuators, communication network, and the applications in the last class. Okay, so now we will be discussing these three layers, like why edge is required, fog layer is introduced, and what happens in the cloud. Okay, so I directly move to that particular topic. See, all things we discussed yesterday. Okay, so let's start with this. IoT data management and compute stack. So as name says, this stack, this part of the architecture is all about data management and the computation. That means processing, right? So when smart object, that is things or the sensors or the objects which are connected to the IoT, that collects the data, right? But processing location will be cloud, right? The data will be processed in the cloud, and then decisions will be taken care, right? So with respect to this, there are requirements that is because cloud is too far from the smart where the smart objects are deployed, right? So the new requirements with respect to this is minimize the latency, conserving network bandwidth, and increasing local efficiency. These three includes need to be these three requirements has to be addressed. Okay, so what you are seeing in this diagram, it is a traditional IT cloud computing model, where you can see endpoints and three layers are given, where endpoints, this is with respect to things or the objects that are connected to the internet, devices or anything that is connected to the internet. And as you know, once the data is collected at this point, it is transferred over the network, right? That is second layer. And then data will be transferred to the cloud or data centers where data will be stored and processing will happen at this place. Okay, this is the architecture or the model that is followed initially. Okay, which includes only 3 layers. Okay, so that is what. So always data processing happens at the cloud, right? So this is the traditional uh, model, and now we'll see we add one more layer for this network, why it is required. Okay, so we'll see that now. So that is what whatever I explained in this slide that is given here. Okay, so with respect to this traditional what model followed, it faces a number of problems with respect to data. The first one is bandwidth is very limited, latency will be high. That means delay is very high, and here the network backhaul from the gateway can be unreliable and depends on the 3G or LTE or even satellite links. That is one more problem. So in the last class we discussed what is backhaul and the gateways, right? So with respect to that, one more problem is there. And next problem is that the volume of the data transmitted over the backhaul can be high because see, all the data has to be, I mean, there may be n number of objects that are connected to the internet, right? At each and every point, huge data will be collected, and this data has to be transferred to the cloud for the processing, right? So see, there may be delays also high when there is huge amount of data that has to be transfer over the network. Then the bandwidth, since the channel is shared by many users data, the bandwidth can be low, right? So that is one. And this here, the volume of data transmitted over the backhaul can be high. And as you know, day by day the data generated, since the count of objects that are connecting to the internet is more, the data generating with respect to that is also more, right? And next is solution for all these data. I mean, solution for all the data related problems with respect to traditional model. We have a solution that is fog computing. What is fog computing? See, the data management has to be distributed throughout the IoT system. See, when you consider this image, I mean, this model, where is it? This model, see, data collected here and processed only at the cloud or the data center, right? So the thing is, the solution for this problem is that we have to distribute the processing system throughout this IoT network. If data is collected here, let some processing work, let it done at this point. Okay, that is the solution, so that we can overcome all these problems. Okay, so that is one thing. Next, that means we have, I mean, the solution is to distribute data management throughout the IoT system as close to the edge of the IP network as possible. Okay, so to do this, we include one service, that is edge services in the IoT, that is called as fog computing. So the processing or the computing which is done at the edge level. Edge level is where the objects or the devices are deployed. Okay, so any device with computing power, storage, and the network connectivity can be a fog node. Okay, and examples where fog computing is followed in industrial controllers, switches, routers, embedded servers, and IoT gateways. Okay, so let's see this example now. Say there are many mining companies that exist in our country, right? So, see, if it is connected to IoT, then autonomous trucks and trays will be used, right, to carry the components from one place. I mean, whatever, the material that have collected to transport that, they may use trains, right, and also tunneling and boring machines to increase the safety of the safety as well as increase the productivity. Okay, So if this is the case, as you know, this process may generate terabytes of data in a single day. Okay, so huge amount of data will be generated because there is number of operations are involved in mining companies. Okay, so if the work has to be done at the 100 feet underground, then you should have a reliable network so that that data has to be passed on to the next layer in the network, right, or in the IoT architecture. So you should have a reliable networks and the cloud connectivity. Usually this will be unavailable if you go underground, right? So to solve this such kind of problem, the fog comes into picture. Okay, what does this fog does? See, this is nothing but a node or any what a device you can say, okay, or a system. Okay, so what does it do? This process the data locally and then upload the data to the cloud at the end of the day. So before what was the procedure that was followed? Collect the data and then passed it to the cloud where the processing used to happen. Whereas in this case, what happens? If you follow the fog layer in your IoT architecture or the model, processing will be done locally. Okay, and then this process data will be uploaded to the cloud at the end of the day. Okay, so that is one simple example which says or which explains why fog layer is important. Okay, so that is, and advantages of this fog is that it allows intelligence gathering such as analytics and control from the closest possible point. That is, it allows better performance over constrained networks. Okay, so because of this fog layer is introduced here. You can see here is the smart object, which is nothing but endpoints. This is core IPv4 network, and between this fog layer is introduced. Okay, so the data will be collected and it is processed at this level. Okay, and then pass it to the cloud over this network. Okay, that is all about fog layer. Okay, now there are characteristics of this fog computing. Let's discuss that. The first one is contextual location awareness. So this is nothing but property of the mobile devices that is defined complementarily to the to location awareness. So to have a awareness of the location with respect to the mobile devices, that is contextual location awareness, and it will have a low latency as well. That means low delay. Okay, geographic. This second characteristic is geographic distribution. As we discussed in the previous topic, the services and application targeted by the fog nodes demand widely distributed deployments. That means the fog nodes has to be deployed over the in a large scale. Okay. So the third one is deployment near IoT endpoints. IoT endpoints are nothing but end devices, objects, or the smart devices. Okay. So this fog nodes has to be deployed very near to the IoT endpoints. Okay, that is what the next one. That is next one is wireless communication between the fog and the IoT endpoint. See, IoT endpoint, as I said, those are the objects that are connected to the IoT, right? So whatever the data it collects, that has to be passed to the next layer, that is fog layer, right? So how do you communicate those two layers? That is with the help of wireless communication. Okay. And the last one is use for real-time interaction. See, many of the application works in real time, right? And this follows batch processing, right? So pre-processing of the data in the fog node allows upper layer application to perform batch processing on a subset of the data. See, some processing will be done at the fog node itself before passing on to the cloud, right? That is what it says. Used for the real-time interaction so that decisions can be taken very faster. Okay, that is about fog. And let's see what actually happens in the fog and the cloud. See, at both places processing happens. Okay, the first point is receive feeds from IoT devices using any protocol in real time. This happens in the fog layer. Okay, and next one, run IoT enabled application for real time control and the analytics with millisecond responsive time. So this is important, right? Even this happens in a fog layer. Next, provide transient storage, often 1 to 2 hours. Even this also happens in the fog layer. Then send periodic data summaries to the cloud, that is cloud platform. See, after processing all this, the data has to be passed on to the cloud on a periodic basis. Okay, and next, receives and aggregates data summaries from the fog nodes. This happens at the cloud. Cloud will receive and aggregates data summaries which is received from the fog nodes. And the next one is performance analysis on the IoT data and data from other sources to gain business insight. So whatever the data that has been received at the cloud end, the at the cloud it perform analysis, right? On the basis of what data it has collected, based on that it perform analysis, and using that information you can move to the business plan. Okay, that is what it says. And the last one is can send new application rules to the fog nodes based on these insights. So whatever the insight that we get it after analysis performed at the cloud, based on that the rules or the information, or you can say guidelines to the fog nodes to follow. Okay, that is what all about fog and this thing, cloud. Okay, so this is edge computing. See here, you can see in this uh, edge computing is a process which is done at the end points, that is at the where the sensor or the smart devices are deployed. See, let's take a smart camera which takes the data, which captures the image. Okay, so that is processed in the what the circuit itself. That is what a device which is or you can see integrated circuit that is integrated to this or embedded into this smart device. So small processing is done at this level itself, that we call it as edge computing. That is computing or the processing which happens at the endpoint level itself, that is called as edge computing. And cloud computing, you know that the data will be collected, I mean the captured data is uploaded to the cloud, where process will be done on that data, and then with respect to that analysis is made, and based on that action will be taken. Okay, this is the cloud computing. And next, that is edge computing. As I said, it is done at the device level where this has been deployed. Okay, and the last part, edge versus fog computing. So fog actually refers to what? Network connection between edge devices and the cloud, right? Whereas edge, what is edge? This refers to specifically to the computational process being done close to the edge devices. Fog, you should understand the difference. Fog refers to network connection between edge devices and the cloud, and edge is what? It is computational process being done close to the edge devices. Okay, so fog always includes edge computing. Huh? That is one thing you have to remember. And this is the hierarchy followed in processing the data. Okay, so as you can see here, edge layer. So this is the parallel part of IoT simplified architecture that we discussed yesterday. Okay, so where the data management and the computing is done. Edge layer, although what devices or the sensors are deployed where some amount of processing is done. Okay, and then it is passed on to the fog computing layer where another set of processing will be done here, and then the data will be passed on to cloud layer. So this is how the data flows or the way that IoT system works. So that is all about hierarchy of edge, fog, and cloud. Yeah, that's all in this class. See, that concludes first module. Okay, so one second. That's it.